Good day to Raja Chanda. Today, we will be presenting our project, which is Management System for FAZANA Computer Shop. Before we begin, let me introduce my teammates. For myself, I'm Nur Sharifah binti Sailan, the project manager. And then our second member is Dayang Mirza Alia binti Awang Razali, which is our database designer. And then our third member is Melanie F. Ashley McClayton. She is our database programmer. Together, we will discuss how FAZANA Computer Shop currently operates, the challenges of its manual system, and how implementing a database management system can improve its efficiency. FAZANA Computer Shop was established in 2018 by Puraida binti Ali, and it is located at Indah Permai Sepanggar, Kota Kinabalu, Sabah. The company specializes in selling computers, components, accessories, and software, while also providing support services. The business aims to become a leading player in the ICT industry by offering high quality and reliable services to its customers. Currently, FAZANA Computer Shop relies on a manual system using Microsoft Excel to manage business operations. It records stock entries, stock exit, item codes, costs, and profits using spreadsheets. However, as the business continues to grow, this manual system presents several challenges, including data inaccuracy, inefficiency, and difficulties in tracking stock and sales. With this in mind, our goal is to develop a database system that enhances efficiency, accuracy, and security in managing the shop's operation. The company vision is to build and secure a leading position in the expanding ICT industry by providing the best products and services to customers. For the company mission, FAZANA Computer Shop is focused on becoming a highly credible and productive computer sales and service provider. The company ensures reliability and customer satisfaction in all aspects of its operations. For the company objectives, to achieve its vision and mission, FAZANA Computer Shop aims to provide high-quality products and services, enhance efficiency and reliability in business operations, and improve customer satisfaction through better service and support. Before we dive into the business entity relationship, let's first understand the current system description. This will give us a clearer picture of how business operations function and the key entities involved. The system consists of three main operations. The first one is stock entry. This refers to the purchases made from supplier, ensuring the company has enough stock to sell. The second one is stock exit. When customers purchase products, stock is reduced accordingly. The third one is financial records. The system keeps track of all transactions to monitor profits and losses. To manage this operation effectively, we have several key entities. The first one is owner, the person responsible for overseeing business operations. And then the second one is manager, manage employees, stock, and transaction. The third one is employee, works under the manager to assist with daily operations. And the fourth one is customer, who purchases products from the business. And the fifth, supplier. They provide products to the company. And then we have purchase invoice, a record of stock purchased from suppliers. And then sales receipt, a record of customer purchases. And then product, the items that are bought and sold in the business. Next is stock, the available quantity of product in the system. And the last one is payment, the transaction made by customer when purchasing product. These components form the foundation of business system. Understanding these entities and their interaction will help us move forward to discuss business entity relationship in the next section. Now I will be discussing business entity relationship and how different entities within a company interact with each other. The first one is owner to manager relationship. This is one-to-one relationship where an owner supervises a single manager. And then the second one is manager to employee relationship, a one-to-many relationship, meaning a manager oversees multiple employees. And then the third one is manager to purchase invoice relationship. In this one-to-many relationship, a manager handles multiple purchase invoices. And then the fourth one is manager to product relationship. a one-to-many relationship, as a manager is responsible for multiple products. Then the next one is manager to supplier relationship. Here, a manager interacts with multiple suppliers, making it a one-to-many relationship. And then, customer to sales receipt relationship. Each customer can have multiple sales receipts, so this follows a one-to-many relationship. And then, customer to product relationship. A one-to-many relationship since a customer can purchase multiple products. And then, supplier to product relationship. A supplier provides multiple products, which makes this a one-to-many relationship. Next is supplier to purchase invoice relationship. Suppliers issue multiple purchase invoices, making this one-to-many relationship. Next is stock to product relationship. A stock contains multiple products, so this is a one-to-many relationship. And then stock to purchase invoice relationship. Stock are recorded in multiple purchase invoices, making this a one-to-many relationship. And then stock to sales receipt relationship. Stock are reduced after each sale, meaning this follows a one-to-many relationship. Next is sales receipt to payment relationship. A sale receipt is linked to a single payment, making this a one-to-one relationship. And then the last one, we have product to payment relationship. Each payment is made for multiple products, so this is a one-to-many relationship. These relationships are crucial in understanding business operation and ensuring smooth transaction. They also help in designing a well-structured database system. Now, I will pass the next slide to my team members, which is Ashley.
Hello, my name is Lynette Ashley McClayton. I will explain the problem statement of our database project. So, FAZANA Computer Shop faces challenges with its current sales management system. And the problems are, the sales transactions are frequently lost due to human errors, and the customer data is at risk, which raises concerns about security and reliability. So, the objectives of this database is to identify the problem in the current system, to design an efficient and secure database system, and to implement the proposed database system. These are the business rules that we propose based on FAZANA Computer Shop's current system. Business rules describe the operations, definitions, and constraints that apply to an organization. For example, the owner and manager business rules states that one and only one owner supervises one manager, while one manager is supervised by one and only owner. The same format applies to the other rules, and these rules are actually based on the relationship, business entity relationship that has been explained specifically by Sharifa earlier. Here we have the entity relationship diagram of our database. There are 10 tables in total, each representing an entity of the business. In each table or entity, there are attributes that define what the entity is. For example, an owner has ID, name, phone number, and email. The same goes with the other tables. Other than that, each table is connected to each other based on their relationship. For instance, since a manager supervises multiple employees, their tables are linked by a one-to-many connectivity line. Overall, this ERD graphically explains how the business entities are related to each other, ensuring a better development of the database. We will now see the third normal form of normalization that were done to the table structures of our ERD. This is a schema design that ensures data is organized efficiently to reduce redundancy and dependency issues. As we can see here, these are the textual representation of the table structures. There's a table name, the entity name, and within the brackets are the attributes of the entity.
So I will be explaining the database implementation. For the first implementation, we use data definition language. So what is data definition language? Data definition language is a subset of SQL. This is used to define and manage database structure such as the tables, schema, indexes, and constraints. It includes commands that create, modify, and delete database object. In this case, the DDL command that we use is create. This is to create all the entities table, defining the data type as well as the sizes for each attributes inside those entities. As you can see, the database name that we create here is FAZANA Computer Shop. We have a total of 10 tables, so I will be explaining in general. For the primary key, we prefer to use the word ID with integer data type. The reason why we choose ID is because it is conventional and it is the standard. Many guidelines for database did prefer to use the word ID for consistency. This makes it easier for us to understand relationship between foreign key and primary key. Next, the reason why we use ID is to avoid confusion. With ID, we can easily identify a unique identifier in each table. Next, as you can see, we use the command not null. Not null here means a constraint that ensures that a column cannot have a null value. It is used when defining a table to enforce mandatory data entry for specific column. Now is data manipulation language DML. So what is DML? DML is also a subset of SQL used to manage and manipulate data within existing database objects. Unlike DDL, which define the structure, DML here focus on the data inside those structures. Now, these are the table records. We have a total of 10 table records for each tables. The second is to retrieve data from multiple tables. The first example, we retrieve all product along with their associated supply detail. We use the command select here is to retrieve specific attributes from a table. Meanwhile, the command from specify the table name where data is being retrieved from. Next, simple SQL queries. The first example, we retrieve all customers who have example.com in their email address. We use the command select with the symbol star. The symbol star here indicates that all attributes is collected from the customer table, where the email like example.com. With this, we can get the output of all customers that have example.com in their email address. Next simple SQL query is to retrieve all products that have selling price greater than 50. We select all from the table product where the selling price is. We use the symbol greater than to get selling price greater than 50. Next simple SQL query. The third is to retrieve all product from electronic category. We select all from the table product where product category we use the symbol equals to get even more specified value, which is in here we want the category electronics. Next is column function and grouping. Here the first example is to get supplier total product quantity. As you can see on the fourth row, we use the command sum. The command sum here is this in here. It is to get stock quantity from the product table, sum it all using the command sum, and assign it as a total stock. As you can see on the seventh row, we use left join. This is to ensure that all suppliers are included. Next is using subquery. For the first example, as you can see, we applied subquery on the 8th row. Before that, I will explain what is subquery. Subquery is basically query inside a query. This query that is inside the query, it will give the output to the outer queue, the result to the outer queue. As you can see on the first example of subquery, we applied it on the 8th row. which is select average, is inside the command where. Select average here will return the result, its result, to the outer command, which is where. The second subqueries is to retrieve all products that have been sold at least once. We use the command inside the command where. The command in here is to check if value match any value in the list.
To summarize, our proposed database system brings several key improvements compared to the traditional manual system. For efficiency, accuracy, and security, the database system significantly improves overall operations by reducing errors and enhancing security. Next is error reduction and organization. By automating stock management, sales, and customer data, the system minimizes human error. And then, better stock management and financial tracking. The system helps in tracking stock levels, monitoring sales, and calculating profit or loss efficiently. Then, data security. Sensitive customer and supplier information is securely stored, preventing unauthorized access. The last one is business growth. Implementing the system position FAZANA Computer Shop for long-term success and sustainability in the ICT industry. With this system in place, the business can operate more efficiently, reduce risk, and improve overall productivity. This concludes our presentation. Thank you for your attention.